Hey guys, today I will be discussing a new question in dynamic programming. So basically this is the variant of the question which we have done earlier, which is there in our channel, that is longest increasing subsequence. So basically this is bit different from that, but the concept or the idea used in that question is same here. So here we have to find the maximum sum increasing subsequence. So first I will show you how to do it, and after that we will code it. Okay. So now let's take an example. If we have elements like 8, 12, 2, 3, 15 and so on. I am taking 5 elements only for the simplicity. Now what we need to do is, the first condition which we need to follow is the sequence which we took is in increasing order always, like 8, 12, 15. This is one sequence which is in increasing order. This is the first condition which we need to meet, and second is the sum which we got from this elements of the sequence is maximum. So we have to find the maximum sum of any of this increasing subsequence. Okay, so now let's see how to do this. Initially what we do is we do this question with the help of the DP, that is dynamic programming, because in the recursive method of this there are many sub problems which are repeating. So for narrow down that, or for not computing that substructure again and again, what we're gonna do is we use the dynamic programming. So we have created a map called memo in which we will store our result periodically. Okay, initially this array which we have created contain the elements as it is. Why this is happens? Because with one element the maximum sum of the increasing subsequence will be that element only, because if we have only one element, let's say 8, and someone tells you to find the maximum sum of increasing subsequence, then it will be 8 only. Okay, so these are the base cases which we have filled in this map. After that, just like in longest increasing subsequence, what we're gonna do is we iterate our I pointer from the first memory location and j from the beginning of the memory location for each ith iteration. Now till j reaches the ith location, we have to increment j and check the condition. Now what condition we need to check? Let's look it out. Let's say first we need to check is the increasing sequence. That means array of j should be less than array of I, because this is the first condition which we need to meet. Without justifying this condition we did not proceed forward. Okay, so we check here that 8 is less than 12. Yes, it is less than 12. Then what we're gonna do is we have to fill this value. Now how we can fill this value? We can take the maximum of array of I, not array of I, the memo of I, the value which is already present at this memory location, and memo of j with array of I. So this is the case we need to do. Like in this case the value already present is 12, and the second value will be memo of j, which is 8, and the current value which we have added, that is 12. So it will result out to be 20. So this memory location will be filled out with 20, because the increasing subsequence, maximum sum increasing subsequence up to this point is 8 then 12, which sum out to be 20. After that we have to increment j, and j reaches here which is at I, so we have to terminate the j and increment I. So now let's look at the next situation of this. We have our I as this at this location and j again initially from this starting location. So we have to first check that array of j is less than array of I. No, it is not. So we have to increment j. Array of j is less than array of I. No. Increment j and j which is I. So we have to terminate this process or this iteration and increment the I. Same like that, we have check starting from 8, it is not less than 3, 12, it is not less than 3, 2, which is less than 3. So what we're gonna fill here is either the present value which is already there, which is memo of I, or the sum of the value present at memo of j, which is 2, and the value present at array of I, which is 3. So it will be 5. Same like that, increment j and it which is I, terminate this loop, and after that the last I will be pointed at the last location and j again starting from the beginning of the loop. Now check, 8 is less than 15. Yes, it is. So change this value to maximum of 15 or 8 plus 15, which is 23. So which is 23. Now increment j, check, 12 is less than 15. Yes. So change this value to either 23 or maximum of 20 plus 15, which is 35. So it will be changed to 35. Then increment the value j, check whether 2 is less than 15. Yes, then change this value to either 35 or maximum of 2 plus 15, which is 17. So it's 35 only. Increment j again here, j will be reach here. Check whether this value 3 is less than 15. Yes, so change this value to either 35 or maximum of 5 plus 15, which is 20. So it's 35 only. And increment j, so j which is I, terminate this loop, and increment I, it also goes bound the loop. So the final answer in this case is 35, but it may not be the case that the last value is only the maximum value. So what we're gonna do is we have to find the maximum value present amongst all this memory location in the memo map, and the maximum value which we got it as our answer. So in this case the maximum value we got is 35. So 35 is our answer. So now let's analyze the time and space complexity. So in terms of time complexity, it seemed like the longest increasing subsequence, where we have run 2 loops. Here also we have run 2 loop I and j. So the overall time complexity on an average goes to O of n square, and the space complexity is O of n, just like longest increasing subsequence, because we are taking an extra map memo of size equal to the number of elements. So now let's look at the code of this using the dynamic programming. So we have created one function, that is maximum sum increasing subsequence, which we call from the main with the arguments as an array which contains a set of elements in integers, and we have the number of elements which is n. Now what we need to do is, initially we have to handle the base cases. Now the base case here is, if we have 0 elements, then the maximum sum of increasing subsequence would be 0 only. Then after that, this is the map which we have created, and I have shown you using the example that this map will contain the values up to that part, that if we take this location, then the maximum sum increasing subsequence up to this location is the maximum up to this point. Now this is the base case of filling this map with that values only, because the maximum sum increasing subsequence with one value is that only. After that, this is the main 2 iteration loop which is used to fill this map again and again iteratively. So this is the condition, which is the value which is already present at the ith location, and the maximum of value present at the jth location of the memo, and the current value. So whatever is the maximum of both of this, we have to take it as our answer for filling this locations, and this location may be modified again and again. So at the end, what we're gonna do is, we have to take the maximum value amongst all these memory locations. So all this memory location. So for that, what we're gonna do is we're gonna store it in max variable and just situate it over this memo map and find whatever is the maximum value, and we just return that. So that maximum value will represent the maximum sum increasing subsequence, which we gonna return to our main function. So now let's look at how we call this function using the main. We have created an array. This is a static array. I have not created it dynamically. You can create it dynamically. It's very simple. Now we have called this function maximum sum increasing subsequence with array and the size of the array. Here I have done manual things, but you can do it automatically by just calculating the size of the array, like size of array upon size of array of 0. So this way you can do this. Here I have done static. Okay, now whatever is the result which we got from the function, we are printing it into our main screen. So now let's look at the code running of this. So if we compile it, it compiles successfully, and if we run it, it is showing answer is 35, which is indeed our case. Okay. So this is how we got the maximum sum increasing subsequence. Hope you like this session. Just stay tuned for the next video. Till then, thank you. Bye bye.